Okay, so now this is the second video on function symmetry, and now we're actually going to try to prove whether a function is odd, even, or neither. Okay, so if it's not even and it's not odd, then it's neither. Okay? And we have an example here: f of x equals 2x to the fourth plus 3. And I've written the algebraic definitions of even functions on the left. Even again means that f of x and f of negative x is the same thing. Odd functions means negative f of x and f of negative x is the same thing. Okay? And so when I have a function like this, the first thing I'm going to do is graph it, because by graphing it gives me a better idea of where to start. I can try to prove that it's even, or I can try to prove that it's odd. And when I have a graph of this, it's easier for me to decide which one to start with. So I'm going to try entering this into my calculator: 2x to the fourth plus 3, and then graph it. And there it is. Okay. And you can see from this graph that there is a symmetry between the left side and the right side of the graph. Okay. And again, but the graph doesn't prove it. The graph gives us a really good idea, and it's probably right, but we want to be 100% sure. And the only way to do that is to prove it algebraically. Okay, so and in here, because it looks like it's even, I'm going to start with it and try and see if it is even. Okay. So I have to find f of negative x and show that it's the same thing as f of x. And so I'm going to write it down here: f of negative x and again, this notation for the function, it just means that I take negative x and I replace x with it. So I write out the function the exact same way: 2, instead of writing x, I'm going to put parentheses there, to the fourth plus 3, and then substitute in negative x. Okay? And then simplify the function. So now I have 2 negative x times negative x times negative x times negative x. I have to do that 4 times, plus 3 gives me 2. These two x's, negative x and negative x, is going to give me positive x squared. Okay. These two x's, I also have the same situation again. Negative x and negative x gives me another x squared plus 3. And if you remember the rule for multiplying bases and their exponents, I have these two here. This is the same base, so it's going to be x to the fourth plus 3. And if you notice that in my final answer for f of negative x, this expression and this expression are the exact same thing. So I can say that f of negative x equals f of x. Therefore, the function is even. Let's try another example down here. I have a function f of x equals 2x to the third minus 3x. And so let's look at this and see if this function is even or odd. And once again, first thing that I'm going to do here is graph it, because it's going to give me a much better idea of where to start. I can just go ahead and try the definition for an even function, and then try again for the odd function. But having a graphical representation of this is going to give me a much better idea. So I'm going to type in 2x to the third minus 3x and hit graph. Okay? And if you recall, the definition, or at least the graphical definition of an odd function, is that if I rotate it around the origin, I'm going to get the exact same thing. Or in other words, if I take this and I turn it 180 degrees, it should give me the exact same graph. Oops, I think I hit the wrong button there. So this is rotated at 180 degrees, and this is the original function. Okay? And you can see that it's exactly the same thing. Pause the video and go back a few frames if you had trouble seeing that. So looking at this graph, I'm pretty sure that it's odd. Okay? But again, a graph is not a proof, and we want to be certain. And in some cases, graphs can be deceiving. So we want to be 100% sure. And if you recall, again, the definition of an odd function is that negative f of x is the same thing as f of negative x. And so I have to apply both of these transformations on the function and see if they're equal to each other. So the first thing I'm going to do here is find negative f of x. And what this means is I literally just write the entire function, 2x to the third minus 3x, put parentheses around the entire function, and then write the negative sign in front of it. And now I simplify. So I distribute the negative sign, and I get negative 2x to the third, a negative here times a negative 3x, that gives me positive 3x. And this is negative f of x. Okay, so I got 1/2 for this, and I want to now find f of negative x and see if they're equal to each other. And so let me write this down here, f of negative x. Okay. And this just means that I write the original function, but instead of writing x, I'm going to put in negative x in parentheses, okay, minus 3. I have another x here, so I have to replace that with negative x again. Okay. And then now I'm going to try and simplify this function. I have 2 times negative x times negative x times negative x. I have a minus 3 here times a negative x, so that's going to become positive 3x. These first two x's are going to give me 2x squared. The two negatives gives me a positive times negative x plus 3x. Also be careful not to mix up these terms here. It's tempting sometimes to just combine these x's with this 3x, but this is all multiplication. This is addition, and so we have to do the multiplication first, because multiplication comes first in the order of operations. Okay. So this gives me 2 x squared, and negative x gives me, I'm going to write the times here, negative x to the third plus 3x. And this becomes negative 2x to the third plus 3x. So this is f of negative x. And now I compare these two expressions, negative f of x and f of negative x. And you can see that they are the exact same thing. So I can say that since negative f of x is equal to f of negative x, therefore the function is odd. Okay. Now I know it's really easy to get mixed up in the notation here with f's and negatives and x, but it's just important to see how it's written and how that translates to the function notation. Okay, same thing here, seeing how this is written, and it's just a matter of replacing x with negative x.